In today's lecture, we're going to be using the skills that we learned from rational exponents and radicals to help us solve radical equations and equations with rational exponents in them. So before we dive into actually the solving process, it warrants a review of some of the things that we've shown you in previous lectures. So I'm going to go to another sheet here and kind of show you some examples that we've done in the past. So if we look at some previous examples that we had with quadratics, we had an equation x squared equal to 4, and so what we were needing to do is we needed to get rid of the power of 2, and we did that by offsetting it with a root of the same value. And so I was taking the square root, and of course if I took the square root of one side, I had to take the square root of the other side using the golden rule of algebra. And in doing so, the root and the power cancel each other out, leaving me x is equal to plus or minus 2. Now, if we were to take a look at this and extend it to higher powers, you could see something of this nature: x to the third equals 8. And so we would take the same premise as we did with the square root, that if we use the root of the same value to offset the power, and we did that to both sides, we could eliminate and get the x variable by itself. And so that's what we're going to do here. We're going to take the cubed root of this side, not the square root, but the cubed root, so that the root of 3 and the power of 3 offset each other. And of course I have to work that on both sides. So now the third root and the third power eliminate, leaving me x is equal to the cubed root of 8. And if you don't know the cubed root of 8, you could simply punch that into your calculator. And of course we want to use the one with the 2 variables in it. So we're going to have the cube root, and of course we're going to tab and hit 8, enter, and that's simply 2. Okay, and so you can see how we could use a radical with a higher value root to do the same thing we did with quadratics and square roots. Now, let's look at the reverse effect of that. Let's imagine instead of having a square, we have a square root of a term, and we need to get the x by itself, but now we have a square root value instead of a power. Well, the same premise applies as before, that the root and the power are going to eliminate each other. And so what we need to do at this point is we have a square root, so we'll want to raise this to a power of 2 so that the power and the root again eliminate each other. And of course whatever I do to one side I must do to the other side as well. So now the root and the power cancel each other out, and then 4 squared is simply 16. So just as we did in square roots, this premise would hold true as well with a larger root value. So let's assume we have the 4th root of x, and we'll make that equal to 2. So the whole idea here is still eliminate the root so that we can get x by itself. Now, before we used the power of 2 to eliminate a square root, so here we're going to use a power of 4 to eliminate a 4th root. And whatever I do to one side, I'll need to do to the other side. And so the power and the root cancel each other out. So x equals 2 to the 4th. Now, if you are unsure about these values at this point, you could just simply use your calculator, and we get 2 to the 4th power, which is simply 16. So that is a good look at the way you can use roots and powers to offset each other, no matter which way the problem is set up. One more example that we may need to look at here is with rational exponents. So let's take, for example, let's say x to the 1/3 power. Now, we know that x to the 1/3 power, let's just make it equal to 2 again, that'll be fine. X to the 1/3 power could actually be rewritten as the cube root of x. So just like the cube root of x, I want to raise that to the 3rd power. I'm going to do the same thing here. I'm going to raise this to the 3rd power. Now, The desired effect here is this. Whenever I raise a power, I'm going to multiply those two values. So when I multiply 1/3 times 3, which is also 3 over 1, I'm going to get 3 over 3, which equals to 1, which is simply going to give me x to the first power, which is an understood value. And of course we don't write that first power, but that's the desired effect that we're looking for here. And of course 2 to the third. And if you're not familiar with that, you could simply see that that is 8. So we get x to the first power is equal to 8, and of course we're not going to write that first power. So you can see how we can use rational exponents, and of course if we wanted to, we could convert it to a radical and achieve the same thing. But I'm going to suggest you get comfortable with taking the reciprocal, of course. This is a reciprocal. Taking the reciprocal of the rational exponent so that you can clear it out and make it equal to 1. So let's go back and take a look at the notes now, and there's a couple examples for us. If you look at example 1 and example 2, notice that in both cases I have this as a, I have, in example number 1, I have a radical term. In example number 2, I have a rational exponent. But in both cases, there is actually a value that is attached, either through multiplication or addition or subtraction. Just like in any other algebra problem, before we can actually use these principles that we've been teaching you to eliminate and get the variable by itself, you need to isolate those parts. So the very first thing you need to do is you need to isolate the radical term, or you need to isolate the rational exponent term. So you can see here first in example number 1 that we add 4 to both sides and we get the cubed root of x by itself, and then at that point I can raise both sides to the third power to eliminate the third root. Okay? And then of course in example number 2, I'm going to have to divide both sides by 2 before I can work on raising, eliminating the rational exponent. And of course if you recognize this, that is the reciprocal. So we're going to take the reciprocal of 3/2, which is 2/3, and of course 3/2 times 2/3 is going to give us 6 over 6, which is going to equal to 1. And so that's going to give us the desired effect of x to the first power. And of course I will need to do that on both sides of the equation. Okay, so that's a good look at solving radical equations using the principles of roots and powers offsetting each other, and then of course rational exponents have a reciprocal exponent that will offset it. So in the next video we're going to look at some of the examples.